Okay, so this is a magnetic disc, how it looks like. These are the platters or the main functioning disc which moves around this spindle. This is a rod around which this platter moves. These are the hands which reads or write the data. We have taken one plate here, and these are the cross sections of this platter on one side. This is one surface, this is another surface. On one of the surface, you can see there are many tracks. This portion in red, this is one track. In mathematics we refer this to a sector, but for this magnetic disk, one segment of this track is referred to as sector of a track, and this will be considered here in COA. And when we continuously place many sectors together one after another, this is referred to as cluster. As you can see, this sector is the smallest unit of the disk which can be read or written at once. So for simplicity, we have taken one diagram. This is a platter which is having three tracks, 1, 2 and 3, out of which I have highlighted one, the middle one, in green color. So when I say that there is three tracks, I can see each track is having four segments, 1, 2, 3 and 4. So on one surface, this is surface 1, on the back side we can see another surface, surface 2. So for one surface we are having three tracks, and each track is having four segments. Each segment is known as sector. So tracks, the number of tracks is 3, number of sectors per track equals 4. So total sectors per surface is 12. As we also know that behind this platter there is another surface, so for one platter we will be having 24 sectors. Now coming to the next part is a cylinder. Cylinder is an imagination, like we considered one track placed over another. Like this is the collection of tracks of same radius from all surface. These tracks are measured from the spindle, and these are all having same kind of radius. So if we pile up one track at a time on all the platters, we will end up forming a cylinder. Now for simplicity, again I have taken one platter which is having two tracks, 1 and 2, and each track is having four segments, this and this. So this platter on one surface is having four sectors, sorry, 4 into 2, 8 sectors. So therefore for each platter we will be getting 8 into 2, 16 sectors. Now as we know how clock timing is measured, like if I write this is the clock, and if I want to write I want to decode this clock and tell it to any person, then I can say it is roughly 3 hours 59 minutes and 35 seconds. This is an approximate measurement for this. In a similar manner, we can show this sector number in this kind of address format. For example, when we write the time, we first find this 60-second barrier. Once it crosses 60 second, we already know once it is 60 second, it is considered as 1 minute. So when we are having 65 seconds, we will write it as 1 minute 5 seconds. In a similar manner, when we are having 60 minutes, we will write it as 1 hour. So previously we have seen this is the smallest unit of the disk, smallest unit. In a similar manner, second is also not the smallest unit, but for this case when we are considering hour, minute and second, so it is comparatively the smaller unit used among these. So in this manner, when we are getting sector number, only the sector number is given, and we want to show it as cylinder number, surface number and sector number. Okay, now we will take an example with respect to these pictures. So sector number 42 is given. We have to write it in this address format. So what we will do is find out the number of sectors in one cylinder. Now what is a cylinder? Like, if I consider this one track, which is this outer one, and trace it down to the last platter, and this is one cylinder. Another cylinder is on the inner side, that is this one. So on one surface we are having four sectors. So on the first surface, that is four sectors. Now we have two surface for each platter, that is two, and now we have three such platters, that is three, which will be 24, which means there are 24 sectors in each cylinder. Now the another thing we need is sectors per track. Now there are two tracks on each surface, and we can see there are four segments, 1 2 3 and 4. Similarly on the inner side, this inner track, 1 2 3 and 4. So we will note it down 4. Now what we will do, we will use this sector number and divide it by the number of sectors per cylinder, which is 24, and we will take the lower bound, which will come out to be. Now for the next part, we will be taking modulus to get the remainder, and then divide it by the number of sectors in each of the track, which is 4, and again we will be taking lower bound. This part will be 18 and divide by 4, which means 4 into 4 16 and 4. Now for the last part, which is the sector number, again we will follow this same thing, and again we will be using modulus. This was 18 modulus 4, we will get remainder as 2. So this is cylinder number, this is surface number, and this is sector number. We'll write it as 1 4 2. In a similar manner, if we are given this address and we want to find out the sector number, like this one, 42 was given, we have decoded it and wrote it as 1 4 2, and we want to revert back to 42, we'll use these formula. Like, this one represented cylinder number, this one was for surface number, this was for sector number. We'll multiply this with 24, which was the number of sectors per cylinder, and this number with the total number of sectors in each track, which was 4, and for this 2 we'll do nothing, just simply add it. This is 24 plus 16 plus 2, which adds up to 42. These are the formulas, you can take a look into it.